In this video, we'll be looking at finding the corner points of the feasible region that's bounded by a system of linear inequalities. So for our example, we have 4 linear inequalities, and what we'll want to do is first graph them. So to graph them, we need each of them to be in y equals mx plus b form. So for our first equation, our first step will be to subtract 4x from both sides. So we'll have negative y less than or equal to 16 minus 4x. Next step will be to multiply both sides of the equation by negative 1. Now when we multiply both sides of an inequality by negative 1, that's going to flip the sign of our inequality. So that's going to be y is greater than or equal to negative 16 plus 4x. And we'll go ahead and label this line. That'll make it easier later on. We'll also color it blue. All right. So for our second equation, 4x plus 2y less than or equal to 22, we'll first subtract 4x from both sides. And then we'll divide by 2. So that will give us y less than or equal to 11 minus 2x. We'll give that one a number and a color as well. Make that y2, and that one will be green. You certainly don't have to use colors on these, but if you have colored pens or pencils, it does make it easier once we graph it. All right, our last two, x greater than or equal to 0 and y greater than or equal to 0, is going to be true of many problems that you work in this section, because x and y are generally a number of items of something. And so, of course, we can't make a negative number of items. So we'll have x greater than or equal to 0, which our calculator won't be able to graph, but y greater than or equal to 0 it can. So we'll write y greater than or equal to 0, and we'll call that y3. And we'll make it red. So now we want to graph these on our graphing calculator. And to do that, we'll click on y equals up on the top left. And we'll type these in the same order that we have them written. So first we have negative 16. So negative 16. Make sure to use the negative sign instead of the minus sign when typing that in. Plus 4x. Our y2 is 11 minus 2x. And then y3 is just 0. Now your calculator has the ability to shade when we're graphing linear inequalities. But if your calculator is like mine and it's just black and white, it ends up just shading the whole screen and it's kind of hard to see. So what we're going to do is just graph the lines, and then we'll draw on the screen the actual graph with the shading. So we'll hit graph, and we'll see our lines on the screen. All right, so let's go ahead and draw that out. Now, since we're only interested where x and y are greater than or equal to 0, we're really only interested in the top right-hand quadrant of our graph. So that's really all we need to bother drawing. So let's figure out which of these lines is which. And to do that, we can click the trace button on our calculator. And we can't see the cursor right now, but if we move it a little bit to the right, we should be able to find it here in just a minute. There it is. And so we can see that the positive slope line, that's y1, which it tells us in the upper left-hand corner. So y1 was negative 16 plus 4x. That was our blue line, so we'll go ahead and draw that line in blue. All right. Then if we use the up and down arrow keys, that'll cycle through the different lines. So if we go down one, our cursor will move to the other line. That's y2, which was 11 minus 2x. That was our green line. And when you draw these on paper, your graph really doesn't need to be that accurate. The main thing that you need to make sure happens is that the intersections are generally in the right place. So notice I made sure that these two lines intersected above the x-axis. As long as it's above the x-axis, you should be just fine. All right, last we'll go down one more time. We'll see y3, of course, is the x-axis, since that's where y is greater than 0, where y equals 0, rather, is the x-axis. So we can draw that in red. All right, so now let's go back and let's shade based on our earlier inequalities. So if we go back and look, we see y1 was greater than negative 16 plus 4x. So when we see this, y greater than, we want to shade in the up direction. So we don't want to think of left or right because y values go up and down. So we want to shade above that line. So we'll look at our blue line right there, and we'll shade up from there. I'll just make these little marks here so that we can see what direction we're shading. All right, and let's go ahead and label that so we remember which line that is, y1. Let's go back up to y2. y2 was less than or equal to. So less than or equal to will be down. We'll want to shade in the down direction. All right, and then lastly, y3, got that one right up there, y3 greater than 0, so we'll shade up from there. Then lastly, we had the x greater than or equal to 0 that we couldn't put in the calculator, since the calculator only has y's that we can set things equal to. But x equals 0 is just the y-axis, so x greater than 0 will just be everything to the right of that y-axis. So what we're looking for is an area that is shaded each of these colors, that's shaded for all of them, where points would satisfy each of these linear inequalities. And so that area we'll outline in gray. And then we'll kind of shade it. That's what's called our feasible region. In that region, every x and y value satisfies each and every one of our linear inequalities. So now that we have our feasible region, we want to find the corner points of that feasible region. And so the corner points are just like what they sound. They're literal corners. So things where two lines intersect. So we'll have one right up here at the top. We'll have one down here at the intersection of these two lines, one down here at the bottom, and then one over here at the bottom left. That's a pretty easy one. That's 0, 0, since that's the origin. So we can go ahead and put that one on there. All right, so now let's find the rest of our points. Let's start with the top left point. We can see that's where y2, which was our green line, where that one intersects with the y-axis. Now that one, the way we'll do that one is actually we have that number already. If we scroll up here to our y2 inequality, we have it in the form y equals mx plus b, where b is the y-intercept. And so we can see that the y-intercept would be 11. So we already have that value. So we can see that that point would have an x value of 0 and a y value of 11. Okay. Let's move to our bottom right point. That's where y1 meets the x-axis, or where y1 meets y3. And to find that point, we'll use the intersect function on our calculator. So we'll hit the second key and then the trace button. We'll go down to where it says intersect and hit enter. And what we want to do is just select the two lines that we want to find the intersection of. And we wanted to find the intersection of y1 and y3. So by default, it'll start off at y1, so we'll hit enter to select that line. And then it'll go to y2, so we'll hit down once on the arrow pad, and that'll take us down to y3. We'll hit enter one more time, and then enter one more time, and that gives us the intersection. That tells us that point is 4, 0. All right, now we'll find our last point, and that point is where y1 and y2 intersect. So we'll use the intersect function on our calculator again. So second, and then the trace button, down to intersect. We want to select both of our lines, so we start off with y1. We'll hit enter to select that one. By default goes to y2, so we can hit enter to select that one, and enter one more time to solve. And we can see that that intersection is at 4.5 and 2. And that's how we can find the corner points of a feasible region on our graphing calculator.